All right, so now that we have set up the rules, let's just look through here to see what we got in terms of tools. So you can start up here. Something that you just should know, if you press edit, you can find some nice tools like the interactive delete tool, global deletions, if, for example, you want to start over or you want to clear all the tracks or something. This is just, you may want to use this somehow. What else? Well, as we said, we need to set up the track widths. So from these design rules, we found that 0.2 millimeters was the minimum track width. We might want to use a larger one. In a lot of places, that's why we have these other options. I usually make a few depending on what we need to use them for. And this can be, for example, so we had shutdown circuit, it will not run more than 1 amp or 1 ounce thickness. For external layers, it will have to be about, it will have to be about this wide, but our current fuse is at 3 amps. I think we'll change it to a 2 amp fuse. So then, you want the fuse to blow first. Okay, I think we'll keep it at 1 because it's probably put a 1 amp fuse in there. Because it's only the air, so they don't pull that much. So the required trace width will then be 0.2, so that's okay. If you have a fuse at 2 amps, then you don't want the traces in the PCB to die. You want the fuse to burn first, so you have to dimension this larger. I'm probably gonna use the 0.2 or the 0.8 for shutdown circuit. 0.8 if you want to be very sure it's gonna be right. For vias, we set these constraints up before. If we do, no, not 0.7 and hole 0.3, we're gonna be okay with the annual rings and the hole size here. And then you have to make sure to select it here. Okay, what else do we have? We have add footprints. This you may want to use if you're adding a logo. So my logo, you can make your own logos, you can add them. This is how to route tracks. If you want to see if they have this black bar, you can swipe out to the left. You can like route differential pairs. You can find other options. To add freestanding vias, you press here. Add field zone. Yeah, we'll get to these different drawing tools, measurement tools, another measurement tool, and a deletion tool if you just want to. Let's see if that works here. Nothing can delete this. Interesting. Yeah. And then on the side you have like if you want the grid, what coordinate system you want, distances, if you want this full crosshair, if you're doing some aligning of things. We'll get back to this later. And here you have all the layers. So you see here we're at the edge cut layer. We can switch in between. It's become relevant later, but front copper, back copper, that's where you route things. Front it is, you don't have to worry about. Front paste, you don't have to worry about. Silk screen is where we write text. That's these white things on the PCBs. The mask is what goes between, or like is added on top of the copper to separate pads of a microcontroller, for example, so that there's well, it makes the soldering process easier if you have like this plastic in between the pads, because then the risk of shorting with solder between different pads is reduced. User drawings, this is just a layer. If you want to do some measurements, you can do it in user drawings, and this will not be sent to the company. This will only be visible in this PCB editor. Front courtyard is like the outline of the components. You have user comments. Yeah, it's useless. Edge cuts, very important. That's the outline of your board, and if you're making holes, you're making it here. And these you don't have to worry about either. I just remove them because they're not gonna be used in the what you send into the company anyways. But okay, say you have some size set up by the by looking at the CAD. I'm gonna do it not in where this one is. So then you can select the edge cut layer by pressing, and you can start drawing that size. So maybe you have a square. Well, then you can see here. You can see, oh, it should have been 7 centimeters long. So you try to make it 7 centimeters. Here, this grid, this is kind of how much you can move, what kind of increments your mouse is moving. So it's moving like in 0.1 millimeters. If you select something very large here, 2.5, you see how it's skipping a lot. Recommend keeping this. You can go 0.1 if you want to make something, but don't begin changing this when you have chosen a net. So here we try to keep the 0, and you see here how we're jumping 0.1 millimeters all the time, and we have to make something that we said 7 centimeters. We go to about 7 centimeters. It's here. We try to keep the angle at 0, and yeah, there we have something that is 7 centimeters, and you can go on and make your size. What Tori has told me is make it very small. So what I will do instead is I will press this button. So you might not see this button. It is because you have to open it as the profile, open the schematic first. Oh no, I pressed, yeah. You open the schematic, then you open the, sorry. Yeah, then you open this, then you'll see this one. So what this does is it adds all the footprints from the schematic. So I press update footprints, and here we had some warnings, but we got some of the footprints. Let's see what it said. So warnings, no net found. That is okay. It's just that we used. So 5, 6, 7, 8. It's probably this one, 5, 6, 7, 8. They don't have a net which they're connected to. You can see here on this Lemo. These are connected to ground. I will get back to this later. But okay, we got these components. Tori told me make it very small. The first thing I do, you can press view here and go into the 3D viewer, and you can see kind of what components you're working with. If they have a 3D model here, this Lemo didn't have it, but still, this is kind of what things are looking like, if you didn't know. And here you can kind of start judging out then. So now I'm doing it with, I can make it whatever size I want. And of course, my PCB has 2 sides. The Lemos are going to be pointing out of the box. So what I want is I now everything is placed on the front side, and you can see it if you click on an item down here. Board side is front. So this is placed on the front of the PCB. Well, the Lemos then has to be placed on the back. So I press F to flip side, or you can press E on any, or right click on any component, and you can get a bunch of options here. I think change sides, let's flip, yeah, F. I recommend trying to learn these shortcuts. It goes very much faster. But yeah, we're gonna change side, flip. So this is gonna be on the back side. The different in color here is that the footprints are made a bit different. Don't care about that. The purple here means it's gonna be printed out the circle on the PCB. This blue is this back fabrication. Yeah, as I said, these are not gonna be visible. So this one will have this ring printed, this one will not. It doesn't really matter. And here you can see this is like the front fab. You don't really need it because it's not gonna be, you see how much extra junk it adds. It gets a bit cluttery to see. So I usually remove this. We have this. We try to put well, the important thing here is this ring you kind of want to keep track of it, because how does a Lemo look? Well, it has this it has this metal part here. So if you take some through-hole component and you place it inside the string, it might touch the metal of the lemo here. Shouldn't, but it might. So you want to stay out of this ring with any through-hole components. Okay, but it's gonna have 2 lemos. Put them here. What else are we gonna have? We're gonna have the relay. Well, actually, we go in here. So as soon as I press anything in here, it gets highlighted in this one. If I press anything in the layout, it gets highlighted here. So what I usually do is I look up my different blocks where these components are doing one thing. Sorry, I'll clear this. So usually, okay, here's the brake signal conditioning blocks. These all components all relate to each other, so the wires are going to be related to each other. So usually it's a smart idea to group these components next to each other and not like take this resistor and put it next to some resistor here that is doing something completely else. That is usually not going to be the way to go. And yeah, if you have things like an OR gate here, U2, it's powered by this block, so these are the pins. You want to make sure that this capacitor is actually close to the pin. That is a very important thing to remember. As soon as you have capacitors, you want to keep them close. So that also goes for the power supply. These capacitors should be close to this because it's filtering. We're removing noise, and you want to remove it at the source and not, and you want to supply it as close to the components as possible. So what I usually do is I pick one of these blocks, start with power, highlight all the components here. Go back here, now they're all highlighted. Press M to move, and I group these. So I know that all of these components are related to this power block. They should say close, we should put them together. So what can we do? Well, what I will start with is just, okay, so we have 24 volts coming in. I try to put the 24 volt stuff next to each other. And by pressing R, you can rotate things. So you want to try to keep the 24 volt stuff close to each other. And now it's a bit of like trial and error always. So we just keep the 24 volt things close. And you see, yes, if I get too close, it's gonna warn me. Think about that you have to solder this, so don't put things too close to each other. I will start spacing things out. See. So okay, this was the 24 volt stuff. We have battery in. Connect there. What else do we have? Yes. If you want to see what any component does, you can press here and you get to this point. So let's see if we have placed all of these 4 components. Yep, they are. Perfect. Let's go to the other side. We want the ferrite plate first. It connects from here. So we'll do move to this. And again, this is the silk screen, is things that are printed. If you're working on a very tight PCB, remove them. It's okay. But if you can, keep them. Then we add all the other things, which is we have some other things connected to 5 volts here. I'll hold it like this. Yeah. And here it's, you know, personal preference. I'm trying to make a small board. I'm doing what I can to accomplish that. See, 5 volts. And I'm not spacing that many crazy close to each other because I don't need to. Just make it super annoying to solder. Okay. Try to move all these things out so we can understand what's what. So when you're soldering this, you can see which component is what when you look in the boom later. Okay, so we place these pretty close to each other, and we try to become happy with the size that this takes up. This is usually how I start. Okay, so we have something here. It looks pretty small. Perfect. Let's move on. Go into this block. these all things relate to each other. It's these things, okay. Now, here's a bit of a special one. You want the diode and the resistor to be between two points here, because yeah, this is a relay. A relay is basically a magnetic coil where you build up a magnetic field. Or sorry, it's a coil where you build up a magnetic field to move a mechanical component to flip a switch. And when you collapse this magnetic field, you want to turn it off. Well, there's a lot of power charged up in the inductor, and it's strömtrög, it's like it wants to keep a constant current. So it will actually push through a lot of current, and you want to have these flyback diodes to make sure you have a space for this energy that is stored up in this magnetic field to quickly be collapsed and take some route here. So these two are going between these 2 points, and we want to keep them close for that reason. So we'll do this, and you can kind of see it here in the very descriptive silk screen that we want to keep this feedback path here close. Here, this also indicates that it's a load. And here is the switching. We have this transistor. I will just try to put it close. This we can change later, so we'll just do something here, okay? It's not super important now that it's super small. You have to look into how it all adds up in the end. For now, I'm fine with doing something like this, just to keep it pretty close and group them. Okay, we go to the next point. Well, the next point would be this. Select it all. Here we have quite a lot of components. We'll take a spot down here. Test point, we don't want to bother with right now. So what can we do? Well, we try to see here. Well, we start with going in order here. So these all belong to the same sub part. Write them out. The OR gate, we have, does the OR gate test a supply probably? U1A, U1B, this is the supply. So the capacitor should go, as we said, close to it. Okay, what else do we have? We have this diode, place it here. This one seems to be connected to this one, so we do these. Here, something between 5 volt and that point. Where's a good place? Maybe we can place it here. Where does this connect to? That point as well, okay. Let's think. And this one, where does it connect? Okay, it just goes like this. Okay, we'll do something like this for now. Again, can change this later. If we feel like we need more tight package. I'm kind of happy with this. Yeah, sure. And this one. That's the capacitor C9. It should be close. We put it here. Perfect. We have the output OR gate. Sure, why not? Look at that one first. Oh, there we go. We do the same as we did for this one. We take the capacitor, we put it close. And as you can see, it's a lot of trial and error, let's say. You can just play around a bit, see what you think looks small. And when you're happy with that, you can move on. So where does this one connect? It connects to here. And for now, don't care about the grounds. I know. And I'll get back to that later. Yeah, between 5 volts and this point, so maybe it can go here. Yeah. This one we can put here. And this one is what it's, yeah. Yeah. Okay, this is looking pretty tight. All right, and these all align to each other. Yeah, this is, by the way, the white lines are what things are connected to what. So you see that ground lines want to point together, and it indicates how the routing is gonna go. So I usually just press R here and select everything and see what kind of makes sense layout wise, but we'll do something like this for now. Don't, don't waste too much time on this already in this process. We have something here, we have something there, we have something there. We'll go to the next one. We did this one, we did this one. So final one is this. This thing's close now. Okay, so what do we have here? This one goes here. And yeah, I'm not at all concerned about the grounds. That will figure itself out later with the use of these ground planes. Okay, so here we have something else. Now everything seems to be grouped pretty well. Yeah, we'll keep it on this side. Yes, I'm pretty happy here. So as we said, we're only restricted by trying to make it small. So what can we do? Well, now it's just a matter of starting to place the components. I like starting off with the connectors and trying to get them in a place where, because they're usually the ones that take up a lot of space. So I try to connect them in a place where it would make sense to connect them to the other PCBs in the same compartment, or things similar to that. I just realized that this component, the mini module, will not be used because this will be in a standalone box. So this one will not be used at all. We'll change this one later. But for now, then I'll just place it here in the corner, and we can change it later. Okay. Place this one here. We can take this relay, big component, place it in the middle. This we place up here. Okay, starting to become happy with this layout. And yeah, just play around with placing things. See where you think you can. We can place them to make it small. Test points, they're pretty important. The test point is just a place to probe. So it has to be in one of the edges so you can access them. And then the connector will be probably on this other side. The external connector. Okay. We have something we are okay with here. Size-wise, so we'll see what is the width. So we go into the user drawings layer, and we just try to get an understanding here of what we're kind of working with. So something like this width and this height. So it's not a very large PCB, 7 times 5 centimeters. Try to imagine that it's not it's not a lot. So I think this will be okay. Then the next step. Now I will make the edge cuts. So the edge cuts, you have to go into the edge cuts layer. This is the outline of the board, as we said. I will start off. You can just make a square, I guess. Just do something like this. But I want to have rounded corners, for example. So then I just make some. I use this arc tool, and I make what's kind of diameter should the rounding be, or radius? Sorry. Do. We do this. Okay, so now we have part of it. And now I will use this full crosshair to just see. We had some distance right between the edge of the board and where we can have copper. This is probably one of the points which we are which are at the outline. This one, these points, that's where we have to stay away. So this one can be pretty close here, something like so. And I will grab another one. I'll put it down here. Okay. I'll grab another one. I'll put it. Yeah, here we can instantly see it. This one has to be moved down. Perfect. Or we just do this. Now we're talking. Yeah, I'll try to. Okay, this looks pretty tiny. It's good. Then we can pull this up now. Oh. Do this one first. Pull it up a little bit. Something like so. No, a little bit more down. Here we go. This one, well, let's see. That's the kind of the point, and we try to keep everything inside. Okay, there we go. Place another one. It's gonna be in this corner. We need it to be about there. Yeah. This one here. Yeah, this looks pretty good to me. Take the straight line tool. And now it's important that you don't just click here. this it will complain about. You have to wait until you get this small white circle. Okay. Like so. Now we go here. If you are super, like, if you really want to, you can spend a lot of time making this angle 0. If one of my angles aren't 0, no, they're all good. 90 or 0 degree angles, which is good. This line is not perfectly straight, but it's so little that it won't matter. And you know, the company can probably not make this exact outline, but do you care? No, you don't. If it's a little, if there's a few millimeters off here in the outlines when they cut it, who cares, right? It doesn't affect the function of the boards. Okay, it's kind of small. We have some dead space here. It's a little bit unfortunate. So is it possible that we can do something about it? This is a bit, I mean, probably, but we can also do this, which I like, which is granting a bit more room here. Okay, I'm gonna predict that this connector is gonna be switched to some Phoenix connector. So I'm gonna put it here actually, because it's gonna probably be some round connector. We'll get some space there. Put the test points here. And perfect. Perfect. I'm pretty happy about this. Another thing you should know here, if you want to make it look super pretty with everything lined up, say you're happy about the distance this is to this component, you can choose the next one. You can press Shift P, or you can do right click and positioning tools, and then you can select this position relative to, and you press this component. Be wary, if you just press the pad, then it will be position relative to this pad. We want it to be, say, footprint D2. And then X direction is this way, Y direction is up and down. So we want to place it 3 millimeters away from this component. And then it gets like the middle lines here are perfect. That was a little bit too far away, so I press Shift P. I go for 2 millimeters. That was a bit close, so maybe something like 2.5 millimeters is ideal. We go to the next one. We select this component, 2.5, perfect. We do this one, select item, this one, 2.5, perfect. Yeah. This one, this one. This one we might want to do 0.5, but this time in the Y direction, so we want to do 0.25. Okay, maybe a bit more. Yeah, I'm gonna manually place it. It's perfect. And then we're kind of happy about the placements here. We see that this could probably move to the left. Do we need to? Not really. This side of the board could be cut off. So there is certainly a way to place more components up here and make it a little bit tighter. This PCB, but yeah, for now, no, since it's a bit uncertain about this one. And we are, as I said, this is a very small PCB. I think this is an okay size. So, next point, add a fill zone. This is now when you make the copper layers. So we can start here on the front copper, for example, and you press add a fill zone, and I just select a point which is outside of the edge cuts. And the front copper I want to be ground, and I want to also make the back copper layer at the same time, and I also want it to be ground. And here you have some properties for the zone itself. This is set by the board's layout as well. But I want it to be ground. and I press OK. And now I just draw some geometrical figure around the edge cuts. So now if I switch between back copper and front copper, you can see that the layers change here. So now I've created 2 layers of this board. So I make it larger because then it will be cut by the board still. So if I go into 3D viewer here, you see we still have this outline. And now you see how everything is green. This is because it's just pre-preg here and F4. If I press B now, it is building the zones. All right, I should actually. So here you can switch between show only zone boundaries, which is kind of the outline of the zones, or if you want to see the filled area. You see here we get an error right away. It tells me to build. I press B. Boom, the copper shows up. Check the back layer, front layer, back layer, front layer, back layer, front layer. See the difference? So of course this is super annoying when you try to route, but you're gonna use this view later. Okay, so now we can see the copper zones, and if we go into the 3D viewer again, now it doesn't have this dark ground, dark green thing. Here this basically set up in the design rules that we needed this clearance between the copper and the edges, so it did this for us, super nice. And everywhere you see this is like at the firmware reliefs, this is where we don't have copper, these dark green things. And you can see how it is around every pad here. This pad has an electrical net, maybe this is 5 volts, for example. So that's why we don't have copper here, because this copper is all ground. So you need to have this cut out so that you don't short 5 volts to ground and such. It's very unintuitive if you haven't seen it before. That's why we have these darker green rings. And these are, well, the holes through all things. This gray thing is exposed copper, exactly as the pads. This is a point you can solder to. Yes, gold as well. Gold is also a point you can solder to. Now in the 3D view, you can already see if there's some issues. So I know this it's a very tall component, taller than this one even. But is there any issues where my connectors will not or will collide with anything? So how does the male receptacle look that connects this point? Well, I know it doesn't stick out this way, for example, or this way, then maybe I would have to move or rotate this component. So some of our connectors are angled, right? And it has happened that you have put an angled connector here and it fits. But then once you solder this component, well, you can no longer attach the cable in. I can actually show you what I mean. I think this was done a bit on the old car, not on the new one. But if you have, let's see here, something angled, yeah. One we have is the MPC4 angle connector. So place this one. You see this blue outline here? This describes where the this courtyard, I said, describes where the kind of the component is within, and this blue one shows where the connector is. This is on the front steel screen. So if I go into 3D viewer now, you see how it sticks out here. It will actually be pretty good if we do it like this. Yeah. So if we disregard these components right now, if I do this, it looks like it fits now. Can agree? But what is the issue? I go into the 3D viewer. How can I put a cable into here? This has a male receptacle that should go into here. It can never fit here. Use the 3D viewer and try to find these things early, because this is a very stupid problem that you can't fix later, or you can try to maybe put this one on the backside and do. But yeah, if this happens on your PCB, then it may lead to us having to order a new one or hack it up and make the boxes ugly, and it's a mess. So think about this. Try to look in the 3D viewer and see that things don't collide. So we'll see. We'll control set this yes, to this point where we have builded. Perfect. Okay, now we have the edge cuts, both front and back. Here you can also set if you have more than 2 layers. If you're doing routing, like if I press V, I switch between these 2 layers. You can, if you have more layers here, you can set up so that you're switching between other layers if your signal layers are, for example, the layers in the middle or something. Anyways, we said we only have 2 layers. The back copper layer is our ground return path. We do not want to place components there, so we're gonna do the routing on the front copper layer. So let's start with the routing then. There's no point in spending any more time playing around. So routing, we make sure that we have a track width that we're happy about, depending on what we're routing. And now you can see that all the grounds, they don't want to be wired anymore. Okay, perfect. So you can either press S or press this symbol to start routing. So I just go ahead, I start routing for the 5 volt, you have to calculate how much current do I think it's gonna go. I know we're gonna do not a lot of current in this PCB. It's a couple milliamps, maybe 10, 20. 0.25 on an outer layer is completely fine. But yeah, use the width calculator if you're unsure. So yeah, I'm just wiring things up here. And this is a big trial and error. Yeah, you saw there, I was trying to do something which it didn't want me to do, and then I got an error and I couldn't place it. Yeah, this is just, it comes with practice how good you get at doing the routing. And you kind of get a feeling for how you should place things, how traces should be routed. Just don't be afraid to start over. So actually, before you start this routing, if you're happy kind of with the placement, I would push to GitHub. Save and push to GitHub so you have a version history and you know that you can go back to that point. If the routing doesn't end up that great, you don't have to control Z back. I mean, you can always do the global deletion once, but yeah, it's good to have GitHub version history if someone else wants to continue from where you were at this point. Okay, so continue with the routing. I route things that are, I don't try to route long traces now. I try to make it look good with the things that are close to each other now. I am actually a little bit disappointed about how much space we have in some places here. I'm trying to think if I can do something cool here to reduce the size. Well, I think this tutorial will be too long if I spend too much time on that. So let's just go. I mean, this is probably an okay size. And now, yeah. Yes, I should say this now. You can do something, a common error you can do is you do this. So what's wrong with this trace? Don't do 45-degree bends. 45-degree bends, the width will be all weird. You have some crazy phenomena that you can read about yourself happening. If you do the 45 degrees, it's a bad habit. Don't do it. Okay, so that's why we do this. And yes, I can route extremely close to this pad, but remember, we want to keep a bit of distance. When you're gonna put your solder pen here, there is a risk that you scratch up trace here, and then suddenly you short 5 volts to break under threshold because you scraped away the covering paint over this trace. And metal to metal, there will be a connection if you put a lot of solder here. So that's why I try to stay away if I can. And I'm just routing things that are belong to the same net. Yeah, here I think I pressed in the middle. See here it says routing point, start point violates design rules check. So I can't do it. If I press correctly, it allows me to do it. So here. Oh, I should mention this as well. This is super important. When routing, if you right click, there are different ways of routing. So now I was doing the shove mode, which means that when I route here, you see these traces adapt to where I'm trying to route. If I use the walk around mode, for example, then they won't, and it will just tell me I can't. So then I will try to find this point by trying to escape another way. So there are different uses for these routing modes. Use what you feel fits best for your situation, basically. And this one I actually have never used. Okay. It highlights collisions. Oh, not that useful. I'll keep it in the shove mode for now. And you know, you can add settings where if I want to route this, let's see, what's a good example? If you want to route a really long trace, okay, this one will be like that. You see how it kind of takes a while before it decides on a point. You can add like different amounts of like how much it tries to calculate the best route and such. It's a little bit strange, but you can find some cool settings to play around with if you want the tool to do more of the routing for you, basically. But yeah, leaving it as standard is also going to be okay. Here I got this 45-degree angle. I want to change it. So there's two ways to move something. Either you press M and you can move it, or you can just click on it and drag. See? You saw the difference? Either I can drag it and the electrical connection stays the same, or I can move it with M and then I break the electrical connection. Same goes for like components. I can move it by dragging or by M, but the tracks, unfortunately, doesn't stay to the component. I think there is probably an option to have the tracks go with the with the component, but it's not something I use. Perfect. Let's see. We go down here now. Just trying to get things done. And you will have to follow me along here. You can see kind of what techniques I use. And don't be lazy in this stage. And if you've been paying a little bit of attention, you can kind of notice that I've been skipping some traces where there are collisions. So here, for example, there's nowhere I'm close down. Maybe I can do this. See, but I have been leaving. I'm doing the simplest things first, just trying to connect things. I'll get back to why a little bit later. So just going around, connecting things together, reducing the amount of white lines. So see already we've done quite a lot. So this one, let's see, we can see what we can do here. Yes, another thing that you shouldn't do. This you shouldn't do either. 90-degree angles on traces here. It's also a bad habit. I prefer doing, as you can see here, that they are not exactly 90 degrees. Here, again, see that, oh, it's very close here. Why can't I just do this? So I try to increase the spacing here. Same goes with this one. That looks better. And try to keep that in mind all the time. So now we're getting into the bit harder things to route. For example, this one, 5 volt going up here. It's a bit annoying. What else do we have? We have this one that's gonna go quite some way and it's trapped here. So I think we are at the point where we're gonna have to route on the backside. So you want to always try to do as much routing as you can on the front side, not necessarily everything on the front side in the beginning, but you want to try and keep the traces on the front. This is because we don't want, I can, whenever, just go to this layer or press V to hop between layers, and I can make a trace on the backside. What happens is that if I have ground here and I have some component, the current will go like this, right? And then it will have to go around this trace because the trace, I will have to build for you to see this, I think. Sorry. No, okay. Sorry. The trace here, you can see, this is copper, this is some kind of net, and it's surrounded by this dark green area. That means the current can't go through here, right? So you'll have to go around. Every time the current has to go around, you're creating ground loops. This is bad for signal integrity. It also increases the loops, right? That's kind of like an inductor. It increases impedance, it increases resistance. So try to avoid the routing on the backside. I'll remove this one. And we'll continue with the routing then. So okay, sometimes you're just not happy about what you made. I think this is as good as it's gonna get. Here we can definitely go up a little bit. Okay. Yeah, we'll keep going. What else can we route here? Can do this. We can do this. You see again, we're very close. Boom. A lot better. This should go. See if we can come. Yeah. See what we can do here. Do do do. Now we're getting pretty close. The white lines are heavily reduced. Still here, there's a lot of crisscross pattern. So now I'm gonna show you what to do when here, for example, I can't get to this point. Well, what you do is you start routing and you press V. This now shows you a via. Now the via is a way to get to the backside of the board. So I place the via. Now you see I'm routing on the backside. Then I press V again, I get another via, and now I'm on the front side again. So what I've done basically here is I've routed underneath this trace. Now you want to keep this very short and you want to minimize them, but it's okay to have them. It doesn't, I mean, if you compare to having to route ground manually, which would be probably okay signal integrity wise, I can't have it, that big trace. Like, imagine how much resistance it is in this line compared to how much it is for the current to have to go to be able to go like this. And oh shit, there's a little bit of a stoppage here, so I have to go around it. How much resistance do you think that induces compared to having a mini trace in in comparison to this width in total? it's quite a large difference. So this is still okay. And what we should do here, any two lines that are, to show it, any two lines that are next to each other like this. You recognize this shape? If you read the TET course, you will. Here, this might be like at 3 volts, and this is at 2.8 volts, whatever. This is a capacitor. So there'll be a stray capacitance coupling in between this. You call it a capacitive coupling. So, I mean, it's okay, but just know that as soon as you start routing things close to each other, they will affect each other, even though it's very, very small things. It can actually play a role in the end, and it contributes to the quality of your measurements and your signal integrity on the boards. So what we do here, having two layers next to each other, they will be quite spaced apart, but if they go underneath, they will also be pretty close. And there's no ground layer that's absorbing or isolating these two. So you want to try and keep the angles at 45 degrees because you have the right hand rule. So if you have a current going upwards here, if you show your right hand, you see how the magnetic field cannot really be coupled with this one because this is going in the 90-degree direction. So there will be no inductive connection between, or the inductive coupling between these two will be less. So that's why we try to keep 45 degrees. Nah, this isn't super important, but yeah, don't do this if you can avoid it. Go back to this size. Okay, what else do we have? Lem signal, we should go all the way up there. This one we can actually probably pull off. Yeah, we go here. Perfect. Something like that. Perfect, perfect, perfect. 5 volts has to go through to a lot of places here. Let's see, 5 volts. No. You go here, 90-degree against this, or yeah, and then boom. Now I connected this upper 5 volts to this lower 5 volt, and this one has to be connected to this in some way. I think here we'll do a bit of a loop. Something like that. We'll do this. So we don't have that 90-degree angle. Perfect. Now that is connected. What else do we have? This one has to go all the way over there. Here we might actually end up with a bit of a longer backside board connection, but sometimes that's just the case. Perfect, and then this one, break on the threshold. Ooh, we have a chance to go up here. Nice. Keep it in the middle. Okay. Do this. Here we can maybe go like so. Doing like overly long traces to avoid routing on the backside is not awesome either. So it's up to you to try and weigh the pros and cons. If I have to do a routing that goes like this, then maybe it's easier to just make a very small or short wire, because of course the longer the wires are, as you could see in the PCB trace calculator, the more resistant it is in that wire, and yeah, it all adds up. Okay, can we go from here. Now this shove mode is really helping out. Can actually go. We'll never reach that one. Let's think a little bit. So if we go out here, do that, and we do that, and now we route through here, like so. Keep it in the middle. That looks pretty good to me. No. I'll just zip here. Okay, I'll get back to this later. To me, all the white lines except these are resolved. So I'll press B. And now a bunch of white lines appear. And it's ground pointing to what? Nothing? This looks a bit weird, right? So what has happened now is that everything is routed, but the grounds are not connected to each other. Like, it's not magical that just because you say this point is ground, it will make it ground. What you have to look at is now this front side. So all the red you see here is what's ground and copper on the front. And how can this copper? So think of it as just copper. This red part here is copper. How can this copper be connected to this one? It's impossible. We have traces that are surrounding it. So what can we do? Well, if we could manage to have the current go through the bottom layer here, then suddenly we could have a connection. So we add a via, place it here in the middle, boom, this is ground. Now, let's see, what happened to the white line? Did it disappear when I placed it? Yeah. This white line, as soon as I place this, it disappears because now there is a connection in between there, and I actually press build again. And you want to have grounded areas everywhere. So you see, I'm just going around. I'm seeing these large green areas. Now make sure you're not placing on any trays. So you can like, don't do this. That would be very, very bad. So try to make sure you're not placing on any trace or pad of any component. And then I'm just placing ground because I want the potential difference and the currents to be able to go through both the front and the back. So adding vias with ground, spreading them out like this is a good habit. And this is the last thing you do. So I'm just making sure we have and you can see now if I place this grounded thing here, we'll see that boom, we create a copper zone here. And now I'm just trying to go around. And if I try to place it in some place where it doesn't fit, if you set up the ERC rules correctly, it will say here violates location. Location violates ERC, for example. So I'm just trying to go around and making these lines disappear. Okay. How do we think this looks? Here we still have an issue, so place it there. And the trick is, if you get complaints that, oh, how can I explain it? Sometimes it doesn't just allow you to place a ground here and everything is fixed. A trick, a little tip is you route a trace out to a via, and that can sometimes fix your issues. But it should be identical, these two solutions. So here, where is the, yeah, this area. It's now problem area. It's the ground, and yeah, fixed here, another problem area. Yeah, for example here, some ERC rule has made it so that this copper island is not connected there. So even though I put ground layer here, this doesn't reach here. So that's what I mean, where you can just press X and I press via and I try to just place it anywhere, like something like so, maybe. And now I press B. And now it is ground. Okay. And that looks pretty good to me if I swap between. I don't see any of the white lines. And I swap between back and front. Here you can see the back has kind of made it so that there's a kind of a blockage for current to go here. It has to go around. And here it has to go through these holes. It's not a big deal. You still have a very large surfaces where it can go through. And if you want to focus even more on the, like just looking at the back layer or the front layer, you can use this tool to highlight the back or the front copper parts. And you can play around with these different viewing modes if you're doing something. Yeah, I mean, you see what they do. Sometimes they're useful. It's hard to say when and when not. Okay, so everything is routed. It looks pretty good. I'm happy with. I'm going back into the 3D viewer. I'm happy. It looks good. As you can see here, probably we could have placed a lot of components here, 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 some here. So definitely this could have been reduced the size. So at this point, you may think like, maybe I should try to move this up here. You can go around and go ahead and do that if you feel like you're wasting a lot of space. It's up to you. I'm not gonna do it now. Of course, don't, because it's gonna take too long. But yeah, this component, I know it looks kind of like this one, but with this outline, of course, I can't put that so it collides with the circles here. I mean, this is on the backside, so it will probably be okay. But as I said, these holes, there'll be a leg sticking through this hole. So if I put it here, there is a risk again that I collide with the metal here. So that kind of makes sense. So I try to avoid that. Now, what you can do is you can try to make sure all of these are visible. If they're not, just delete all of them. But if you can kind of make it clearer, it's almost better to look in the 3D view. If you think that these numbers here makes it clear that this is R16, C1, U1, D12, K2, R10, R. If you think this will make it easier for you to solder this PCB, keep them. If not, if they're making it maybe so you're making a mistake, remove them. This one, for example, will definitely maybe create issues. This one as well. I will remove them. Don't want to add ways to make faults, if that makes sense. This one, for example, is stupid. We can put it there. Here we have an issue. I would maybe do this. This looks good. And don't worry about the tracks. This is sprayed on top of the tracks. It'll be visible anyways. Yep, pretty happy about this. Then you can go ahead and if you want to press A to add components, you can add, I'll add my logo. So I made this one now. So I find a spot, maybe here. Here actually is a lot of space. And you can add, I don't think I have it, fortunately. Logo. I only have the old ones. um, I'll steal it from some other board. We have our KiCad from the student logo, of course. This one. This one you can take and you can add it somewhere where it looks nice as well. Yeah, the via holes will definitely fuck up a little bit the text, so try to find a spot where it looks decent. Maybe something like this is okay. See if I can add the logo somewhere. I will keep it here in the corner. And then here, for example, this is the lem signal test point. I will definitely then take the text. I will write on the front tilt screen. We said 1 millimeter was the smallest. I will write lem here, so we know that this test point is lem. Okay. So you want to make sure that your silk screen helps you in the soldering and debugging and using phase. So this is the brake pressure. Oh no. You want to make sure that silk screen helps you. So here I add like brake pressure and lem. So when I look at this PCB, I can look at this point. I don't have to open this PCB in the KiCad. I can just see it in real life, and I can see that this is the lem sensor test point. This is the brake pressure test point. This helps me a whole lot, right? So you kind of think like that, and then you can add. If you go to front tilt screen, where you can add like this is PCB main. You know, usually like this, and it's version 2 now. Perfect. And then I made it, so it's always nice having your name and stuff. If you are redoing an elder's PCB and you're just like doing smaller things, because this one is actually made from the beginning, the schematic by Jordi, so I will keep Jordi's name in the schematic here, but the layout is completely done by me. So, and actually Filippo helped out, so, oh, sorry, Filippo. I can guess your, no, I can't. Can't guess how I spell the Italian names are. No, no, no. I will dox myself. Okay, give me a second until I find out exactly how to spell Filippo's name. Sorry. Okay, very embarrassing. Sorry, Filippo. There we go. So, me and Filippo doing this one. Perfect. Yeah, but if you're redesigning some Elder's board, leave the name in. They probably like for here for the schematic, you're made pretty much everything. Filippo made a lot of good changes, so he should write. I usually write like for the AMS. I made the layout, so my name goes on it, but I also put Jordi's name on it as well, because he helped out a lot and he made the original PCB. And how I do it here in the layout, I mean, I keep Kim and Jordi's names because they were a big part of this. I didn't do all this. I updated it, but I didn't do all of it. And sometimes I like to write like updated by Emil Tagesson is usually what I kind of write if I'm doing smaller things. So yeah, don't take credit for others people's work. Yeah. Are we happy with this one then? No. We need to run the design rules checker. So here you can see if you have violated any rules. So we run this one. So we have 95 errors. Okay. So it thinks that all my vias here. It's the yeah. It thinks that every single via I made has a too small hole. So this size I made here is probably too small of the via sizes. Now there's two ways you can go about it. You can either go for you can change all vias to some other signs, or you can check if your design rules allow your holes to be a little bit smaller. So that's the two options you got. I'm pretty sure we can go smaller in the hole sizes. Preferred minimum via hole size 0.2. Okay, maybe I can go into here and I can check what my minimum hole size was. Okay. So the annular diameter is 0.2. This makes this one 0.6. What did the errors say? That they are actual 0.3 and it wants it to be 0.4. It's this one. So if I do this one 0.3, they all disappear. Good. So then you have to kind of check in the design rules. Is it okay if I go 0.3 here? Well, that rule was for, I don't remember where we found this rule, but then you should go in now and check that, okay, I'm not violating any other rules. So go back and check that when you're changing. Just don't change the design rules because, yeah, again, can make the board a whole lot more expensive. This thing is okay. This is a standard size I usually use on the vias. Or is it? Maybe I fucked up here. I actually have to check in a project where maybe I usually do it 0.4. No, I usually use this via. Okay, it's okay. Perfect. What else errors? Okay, yeah, I know what these errors are. Thermal relief. Yeah, incomplete. Spoke count 2, actually 1. What does this mean? It's this error. So if we look in the board here, there's only one thermal relief cut, or only one spoke. It should be 4 ideally, or like this one which has 3, this one which has 4, this one has 4, and you have all this area which is not copper, which makes it easier to solder. This will just make it harder to solder. I'm okay with that. So you can either exclude the violation, change the settings, or change severity to warning, then it disappears. Oh wait, now I don't have any errors. That is perfect. 78 warnings. What are they about? Via is not connected or connected to only one layer. This one. What does that mean? Oh yeah, I didn't need to have a via there. I'm just doing this. Probably I went around and I placed a via there. Okay, so it's fixed. What else do we have there? Current configuration does not, yeah, sorry. This one, not in my footprint library, so it's gonna complain. We don't care. You can always like exclude the violation. Oh, this one is important as well. Schematic parity. So this is if there's any difference between the schematic and your PCB. So no pad found for pin 6 in schematic. Yes, this is okay. That's because on the Lemos, the counting of the pins in the footprints is like 1, 2, 3, 4, 5. 6 doesn't exist, and it's 7, 8, 9. And if you want to make this ground, you either do this way, where you make 6 not connected to anything, and you connect these to ground, or as I did on the other one here to show you the difference. I have these pads, they are nothing, right? They're not connected to anything. If I press, okay, I should show it you like this before. You see, they're not connected to the front or back copper. If I press E, or I right click and I go to properties, I can make it ground by pressing ground, okay, and then press B, and now it's connected to ground. So if we go ahead and do that here. And why we do the Lemos ground is because we may want to use the shielded cable. And if we want to use a shielded cable, we can ground the Lemos from here. And the shield can then be attached to the casing of the Lemo. And this is a very easy way to ground things instead of having to somehow run a cable from the screen shield to ground. Like this is the way I want to do it. And now when I press B, boom. Everything is grounded here in both layers. Perfect. So we can run again. And I was gonna say text thickness out of range for all of them. That's because you see here that they are very close. Minimum thickness 1530. Actual 0.5. You can either change this, or I'm not gonna care because this would just make the text a little tiny bit less readable. So I'm gonna ignore all text out of range things. Out of height, same here. Just makes it less readable. I don't care. Firmware relief is the ones you have left. And silk screen overlap again. I don't care. I can. It's that I should do this. No, it's okay. It's about readability. And what's this one saying? Duplicate footprints. Do you have 2? No. Okay. Well, I don't care. Doesn't really do anything. Extra footprint, I mean. I know it's an extra footprint. I know it's not in the schematic. I don't care. Did we have anything other in the schematic parity? Let's see. No pad found in pin 6, that was okay. No corresponding pin found in schematic pad 8. That's okay. And this is all for J2, these ones. Yeah, these are not in the schematic, that's okay. Extra footprint, my logo. Also okay. No, but yeah, so we're all okay with this. Then I am happy with the board. And this is kind of how you can make a PCB. So now we have this. Yeah. Hope you learned. Yeah. Okay, so there were some things I saw when I looked into people's PCBs. Common one is your routing here in the front copper. You write text, something, and you place it. What have you done now? This is this is like copper. So now it's not gonna be in the layer that you wanted to. This is in the copper layer. So it's actually like copper that you have cut out. This is not the way you want to do it. Select the silk screen layer when you want to use the silk screen, which is for writing things like this. Yeah, frequently use the 3D viewer. If you're working on the back side of the board, you can go to this flipboard view. And this is like you change this perspective, you're looking at the PCB from the other side. I told you already about the connectors that can intersect. Yeah, I use. Yeah, now it looks weird here because we had the text. Use this view to try and minimize these green areas, or the areas without copper, so to say. Good idea. And yeah, if you, yeah, we'll leave it at this. We can do more advanced stuff later. Let me think 2 seconds if there's anything else that I saw. No, for now I think this is okay. So thank you for watching. Good luck with your designs.